When you deal with solving equations where there's a radical involved, it's important to realize that the radical indicates a root of some sort. If the index is missing, it's the square root. If there's a 3 there, it's the cube root. And that is going to determine what you do to solve it. To start with, I'm going to unpack example A for you. If I give you an equation that looks like this, the first thing that you ask yourself is the radical alone. Okay, is the radical alone? In this case, the answer is yes. I've got a radical on one side and a number on the other side. By the way, is this a square root, cube root? Square root. Since it is a square root, identify the root and then square it, or cube, or to the 4th power, whatever the index says. Okay, it's kind of hard to write that, but whatever the root is, you do that to both sides. So I am going to square this side, and I'm going to square that side. Okay? So, in this case, because it's a square root, we square both sides. Okay? So, the square root of something squared is whatever the something was. So the square root of 2x minus 1 times the square root of 2x minus 1 is 2x minus 1. 3 squared, 9. Isn't that pretty? Just killed off that radical in one fell swoop. Easy to solve from here, isn't it? Add your 1, divide by 2, and you should have come up with a value of x equaling 5. But wait, there's more. We're not done. Okay? With roots, you're going to learn a term later on. It's called extraneous roots. Sometimes the root will not result in a correct answer. In this case it will, but sometimes it won't. So we're going to check ourselves. The square root of 2 times 5 minus 1 equals 3, I hope. The square root of 2 times 5 minus 1, square root of 9 is 3. That is true. Okay? The square root of 9 can be a 3. It also can be said, you know what, I'm going to stop right there. Okay, that's example 1, the first one. Now, if I look at letter B, we've got 2 cube root x minus 1 is 3. Do you guys remember the first question I asked previously was, is the radical alone? Well, in this case, the radical is not alone. The radical has a 1 attached to it. It's a separate unit, but it has the 1 attached to it. So we're going to get it out by adding it to the other side. So remove the extra item because you want the radical alone, if at all possible. Okay, so now I have 2 cube x is 4, right? So is this a square root, cube root, 4th root? Y'all can see it's a cube root. So we are going to cube both sides. Okay? So cube both sides because this is a cube root situation. You square both sides when it's a square root situation. You cube both sides when it's a cube root situation. 2 cubed is 8. The cube root of x cubed is x. 4 cubed is 64. So you're going to say the answer is 8. Okay? You're going to say the answer is 8. Check yourselves. 2 times the cube root of x minus 1 is 3. 2 times the cube root of 8 minus 1 is 3. The cube root is 4. And that is true. Okay? Any questions about example 1? Example 1 so far? Not too bad, right? Not too bad. It works the same way. Here's another extra. I'm going to do this one. Even if the equation looks a little weird, like maybe it says negative 3 plus radical 2t minus 1 equals 0. Just because I've arranged it a little bit oddly doesn't mean I do anything different. I'm still going to clean it up so that my radical is alone. Okay? And add 3 to both sides, and I end up with the square root of 2t minus 1 is equal to 3. Okay? You want radical alone, and then we're going to square it. Both sides are going to get squared because we are dealing with a square root situation. 2t minus 1 is 9, 2t is 10, t is 5. Okay? Plug it in. 2 times 5 minus 1 is 9. The square root of 9 is 3. 3 and a negative 3 can be a 0. Okay? Like I said before, the key here is getting that radical alone and continuing with that thought process. Example 2 is just a little bit uglier, but it doesn't make a difference. 3x minus 5 square root of x equals 2. Well, I am going to somehow get that radical alone. You could subtract the 3x, but I prefer to keep my radical term positive in my mind. It just is clearer to me. So I'm going to subtract 2 and add 5 radical x. 5 radical x. So I've got 3x minus 2 equals 5 radical x. Square root of x, so we're going to square both sides. Okay, this squared is simple, it's 25x. The other side, the old pattern from Algebra 1, a squared twice the product of a and b, b squared. So we're going to square our 3x, which is 9x squared. The product of a and b is negative 6x, so minus 12x plus 4. All of that is equal to 25x. If I subtract my 25x over, I know I'm kind of running out of room on my page, I end up with 9x squared minus 37x plus 4 is equal to 0. And we're going to find factors of 36 whose sum is 37. It's already factored for us, so I'm not going to waste your time. X minus 4, or 9x minus 1, x minus 1 equals 0. So if I solve both pieces, x is equal to 4, x is equal to 1/9. Okay? X is equal to 4, x is equal to 1/9. Remember how I told you need to test? Because there are times when both don't work. They produced a root, but when you plug it back in, it doesn't work. This is one of those occasions. We're going to find that the 4 is true. Okay? 3 times 4 is 12. 12 minus the square root of 4 is 2. 5 times 2 is 10. 12 minus 10 indeed is 2. This answer does check out. Okay? But I want to plug in the 1/9 for you. 3 over 1 times 1/9 minus 5 times the square root of 1/9 is 2. Okay, so I plugged in 1/9 for x. Okay, plugged in 1/9 for x. So this becomes 3/9, which is 1/3. This becomes 5 1/3, 5/3. If I did my arithmetic correctly. Does that indeed equal 2? Definitely not. Okay, it equals a negative 4/3, but it does not equal 2. So we find that this is what's called an extraneous root. They give you a little bit of a definition there of what that means. It came up with a solution because we were able to factor it, but this does not actually satisfy the original equation. Okay? So always, always, always check. If you have one of these, you might show me this and this, but then you're probably going to do that. Okay? To show me that you were clear on the fact that the 4 worked, 1/9 didn't. But if you don't test them, you're not going to know. Okay. Last thing for today. I don't want anybody's brains bleeding here. I'm skipping 3. Do it tomorrow. Solve this mess without squaring both sides. Okay? So what they're saying is up to this point, what you've done is you have isolated the radical and squared both sides. There is another way to do that. And I'm going to show it to you here real quick. If you recognize, this is saying 3 times x. And this is saying radical 5 times x. You don't really think of it that way, but x is being multiplied by whatever the square root of 5 actually is. Okay? If we maneuver some stuff around, like if we take that x radical 5 over here, and then we factor out our x. Again, this is going to seem a little weird. X times 3 minus radical 5 is 2. And then we divide to get that x by itself. 3 minus radical 5. 3 minus radical 5. I now have x is equivalent to 2 over 3 minus radical 5. If you remember from previous lessons, however, you cannot have a radical in the denominator. So we learned the term the conjugate. We learned that when you have a scenario where it looks like a plus b times a minus b, which here would be 3 plus radical 5, 3 plus radical 5, this allows us to create a numeric denominator. So 3 squared is 9 minus square root of 5 is 5. Square root of 25 is 5. And that is 2 times 3, which is 6. 2 times radical 5, which is 2 times radical 5. So you end up with this over 4, and you could see that you can reduce it a little further, especially if you pull it out. You pull a 2 out of this, you end up with 2, 3 plus radical 5, 2 over 4, that becomes a 1, that becomes a 2. Okay, so there's your end result. Okay, you could also reduce it here. You might not visually see it, but you can. Okay, I like doing it this way because it makes it real clear for me what I'm left with. 3 plus radical 5 over 2. Okay, I want to do another example like example 4. I want to do another example like example 4. This is going to be a simple one. Okay, so here's an extra. This is another one like example 4. Here we go. Shoot, I lost my place. I'm trying to find a good one. Here we go. So 3x equals x radical 7 minus 2. We're going to do the same thing what we did before. We're going to combine the x's on the left and then factor it if at all possible. So it'll look like this. 3x minus x radical 7 equals negative 2. Factor out the x and I end up with x. 3 minus radical 7 equals negative 2. Divide by this item here because we want to have x by itself. So we end up with x equals negative 2 over 3 minus radical 7. Multiply by the conjugate. 3 plus radical 7. It's just like taking a plus b, a minus b, like the difference of squares on the top and on the bottom. And on the bottom, 3 times 3 is 9. 7 and 7 is 49, which is 9. Oh, that can't be right. Did I pick one that's a zero? That's no solution? 3 times 3 is 9. Something wrong? Hang on, pull out the 3x. Pull out the x for the radical 7. 3 times 3 is 9. 7 minus. So, square root, 7 times 7 is 49. 7, Mrs. Myers. Why did you write 9? Okay, and then the top is negative 6 minus 2 radical 7. 2 times 3 is negative 6. 2 times radical 7 is 2 radical 7. Run out of room. The bottom becomes a 2, so it's negative 6 minus 2 radical 7 over 2. 6 and 2, you can pull out a 2, and that's going to reduce it to negative 3 radical, or negative 3 minus radical 7. Negative 3 minus radical 7. Sorry, I squeezed that in there like that. The 6 and the 2 reduces to the negative 3. The 2 and the 2 reduces to a negative 1. And that's your end result for what x is. Probably should have gone to a new piece of paper instead of cramming it. Okay?